Hello all, it's an honor to meet you here in my video presentation. First of all, before I begin my presentation, I would like to say thank you very much to the Ahmad Dahlan University Yogyakarta for giving me a chance in the first conference on the Internet of Things and Embedded Intelligence 2020. In this research, the first author is Imade Gusti Ngurah Desnanjaya and myself as the second author. In this conference, the title of our research is Home Security Monitoring System with IoT-based Raspberry Pi. I will start my presentation. Home. Everyone have home. Home is the place where all happiness exists. But sometimes you have to leave your home to get work or go on vacation for a long time. When your house is empty, does anyone make your home safe? Safe from fire, gas leak, and theft. In some home environment, security is already available, but they have to walk around to check and contact the owner when something happens. This is an example of data that indicates that level of crime against where the home is empty, and also the risks of fire, electrical zipper, and gas leak when homeowners are traveling. In the market, there are several types of home security systems, but some examples of products offered are less than provide more flexibility in their use. In this research, we'll add several sensors, namely PIR sensor, DH222 temperature sensor, and MQ2 smoke sensor, and sending information in real time using the Telegram Messenger application that's an automatic answering account. In this paper, we use the system development lifecycle method to develop the tools with the following stages. First, planning. From the result of identification, problems that often occur include free room access, free access without knowledge, lack security, and room temperature information. And the second stage is analysis. After knowing the problem and make a general description of the system, this stage analyzes the needs in designing and building system. The third stage is design. The stage of design are follows: preparing the system design, system configuration validation, and choosing the best system configuration. And 4 is implementation. Implement the design, namely prepare tools and material, install the controller, set up all component modules, install the entire component library, and system coding, we made the code program. The fifth stage is testing. This process will be tested to find out how resistant the system in processing information data and implement reviewer. And the maintenance. After the process of testing and integration, the system will be updated or maintained if the user wants to add the new feature or modules that may be developed again for previous system. After knowing the problem, we made the design of device. The security monitoring system hardware consists of several component modules, namely gas sensor, PIR sensor, temperature sensor, and module camera. The hardware connected through two events, namely via Wi-Fi and Ethernet. The protocol for communication between Telegram and system via the Proto protocol. Overall, this protocol will allow the security monitoring system hardware to communicate with the Telegram. Our goal is to design a device that can monitor the condition of the house and is easily to design. Next, we will design the device. First, we made a design for connecting PIR sensor to the Raspberry Pi. There are 3-pin PIR sensor, pin for VCC, output, and ground, and we need to make each pin connected to the Raspberry Pi. And then we make the connecting MQ2 sensor with the Raspberry Pi. On the MQ2 sensor there are 4 pins, namely VCC, ground, analog and digital pins. And we make each pin are connected with the Raspberry Pi. Nonetheless, we made the design for connecting the DTH22 sensor to the Raspberry Pi. And we need to make each pin connected to the Raspberry Pi. In the developing device, we also need some software including Raspbian, Telegram Messenger, and Python. When making the project for the first time, we need to install and some configuration on the software. On the Telegram Messenger configuration, open the Messenger Telegram in the search menu when typing bootfather to create a new boot on the Telegram. Create a boot on the bootfather by sending with the /new boot command. Bootfather will automatically send the token from the boot that we have created. And we need configuration Raspberry Pi. Raspbian is installed on the SD card, which is then installed on the Raspberry. Raspbian is burned on the SD card via PC that has Windows and the ITER application installed. Select the storage destination to burn Raspbian operating system. Here selected the SD card that will be used. The application will burn the Raspbian OS to the SD card with the flashing indication on the application. Before we made the program code, we need to configure Raspberry with the PIR, Raspicam, and the Telegram Messenger. First, we need to update the Raspbian by typing get update. Second, we need to upgrade the component from Raspbian using get upgrade. And last, we need to install all the library of the hardware component that will be connected to Raspberries, such as Telegram and Raspicam. With command get install Python pcamera and get Python Telegram. After all is prepared, and then we make the program code in Python language. But in this case, I will explain with the flowchart. This is the following flowchart from sensor DHT22 or temperature sensor. These steps start when the user enters the command from the boot telegram into this Raspberry Pi. And then the sensor DHT22 will read the temperature in the room and send the result to the boot telegram. The result of the reading are temperature and humidity on the boot telegram. And this is the flowchart of the MQ2 sensor. These steps start when the user enters commands from the telegram boot to the Raspberry Pi, and the sensor will read the gas density. The first condition, if the density is less than 50, the information gas density is safe. And the second condition, if the gas density more than 50 and less than 250, the information gas density is free. And the third condition, if the density is more than 250, the information is the gas density is dangerous. And the last diagram is the flowchart of PIR sensor or infrared sensor. The sensor will detect the movement. If the movement is detected, the LED lights up and the P camera takes a photos. If there is no movement, the camera will not take photos. After all, this is the final result from our research is a home security monitoring system with IoT-based Raspberry Pi. We can see there are temperature sensor, Raspicam, PIR sensor, and smoke sensor. After all processes are finished, we do a test to see the capabilities of the tools. The first test is to find out the temperature of the room. We can send command /temp from the telegram through to boot account. In the figure, you can see the temperature information sent by the DHT22 sensor. In this figure, room temperature testing is carried out in a room that does not use the air conditioning. We also need make a temperature monitoring graph. Here's we made with thingspeak.com. ThingsPeak is a website that provides a graph for IoT project makers who want the process data to display a graph. The second task is to find out the movement of objects in the room. The detected object movement will be sent automatically every 5 seconds to the boot telegram. And the result you can see in the image that we included. And the third task is to find out the gas density in the room. We can send the command /density from the telegram through the boot account to know the gas density in the room. In the figure you can see the result of the gas test. The result of the gas test in the room. In this MQ2 sensor program code, the threshold of the detected gas is determined. The gas threshold detected is carbon monoxide gas, which refers to air pollution standard index. Here is the conclusion of the research. Based on the result of research that has been done, it can be concluded that in design and building a home security monitoring system tool with Raspberry Pi based on the Telegram Messenger, there are several steps, namely the design of the tool, the assembly of the device on the casing, making of the program, and testing of the tool. We already tested the tool and the result is the tool can be running well. After testing, this home security monitoring tool can be early warning if there is thief, gas leak, and fire. And the tools connected with the Telegram Messenger with the help of Wi-Fi connection and were able to send a message in real time to house owner. In the end, I will say thank you very much for the attention. I hope this presentation has given us new insight on the Internet of Things and embedded intelligence. Thank you.